There is one habit that research shows reliably makes you smarter, sharper, and more mentally resilient, and it has nothing to do with books, puzzles, or learning a new language. It is not a supplement. It is not a diet. It is exercise, specifically aerobic exercise. Neuroscience has now established that aerobic exercise does something remarkable to your brain. It physically grows the region responsible for learning and memory, raises the protein that drives intelligence, and outperforms virtually. A landmark study published in PNAS by Kirk Erickson and colleagues at the University of Pittsburgh took 120 older adults and randomly assigned them to either aerobic walking or stretching for 1 year. After 12 months, brain imaging showed that the aerobic walking group had grown their hippocampus, the brain's primary memory and learning center, by 2% on average. The stretching group showed a 1 to 2% decrease. The research behind this video is some of the most rigorously studied in cognitive neuroscience. Erickson and colleagues' 2011 PNAS paper is the definitive human RCT on exercise and hippocampal growth. John Rady's 2008 synthesis of exercise and brain science, SPARK, brings together decades of neuroscience research on this topic. Chaddock and colleagues published similar hippocampal findings in children in Neuropsychology. And Van Praag and colleagues in Nature Reviews Neuroscience documented the neurogenesis mechanism. The dominant model in education and productivity culture is that getting smarter requires purely cognitive work, reading more, learning new languages, doing brain puzzles. Research challenges this not by dismissing cognitive training but by showing that its effects are modest compared to exercise. Studies directly comparing brain training software to aerobic exercise consistently show exercise producing larger gains in memory, attention, and processing speed. The hippocampus, your primary memory and spatial navigation center, shrinks with age at a rate of approximately 1 to 2% per year from the late 20s onward. This shrinkage correlates directly with memory decline and is one of the earliest measurable changes in Alzheimer's disease. Research has identified aerobic exercise as the most powerful tool to slow, stop, and partially reverse this shrinkage. Research comparing sedentary individuals to aerobically fit individuals across multiple cognitive domains consistently shows significant differences. Aerobically fit adults show faster processing speed, better working memory, greater attentional control, superior executive function, and more robust learning consolidation than their sedentary peers. These differences are not explained by baseline intelligence. The aerobically fit group acquires these advantages through fitness. Studies in children show that aerobically fit kids have larger hippocampi and score better on academic tests. The mechanism behind exercise's brain benefit centers on BDNF, brain-derived neurotrophic factor. BDNF is often called miracle grow for the brain. It promotes the growth of new neurons, strengthens synaptic connections, and enhances the brain's capacity for learning. Research shows that a single bout of aerobic exercise significantly raises BDNF levels in the blood and the brain, with the hippocampus being particularly responsive. Chronic aerobic training produces sustained BDNF elevation and permanent structural brain changes. BDNF rises rapidly after aerobic exercise. Research shows that a 20-minute bout of moderate-intensity running or cycling elevates serum BDNF by 20 to 30% above resting levels, effects visible within the first minutes and lasting 2 to 4 hours afterward. Regular training produces chronic baseline elevation of BDNF that is measurably higher in aerobically fit individuals compared to sedentary peers. Research has documented cognitive improvements from aerobic exercise across multiple domains. The effect is not limited to memory. It extends to attention, processing speed, executive function, and creative thinking. A meta-analysis of 37 randomized controlled trials found significant improvements in executive function, attention, and memory from aerobic exercise programs. High-intensity interval training shows particularly rapid BDNF elevation, but sustained moderate-intensity aerobic exercise shows the strongest structural brain changes over time. Neuroscience research has also mapped how exercise timing relative to learning affects memory consolidation. Research shows that exercising before learning improves encoding, the initial formation of memories, via elevated BDNF and increased hippocampal blood flow. Exercising after learning improves consolidation, the stabilization of newly formed memories. A study found that participants who exercised 4 hours after learning a word association task retained significantly more information 48 hours later than those who exercised immediately after or not at. The research-based framework for using exercise to become smarter has 3 elements. First, consistency. Chronic aerobic training produces the structural hippocampal growth. This is not achievable with occasional exercise. Research shows hippocampal growth in humans requires sustained training over months. Second, intensity. Moderate to vigorous intensity produces the greatest BDNF elevation. Casual walking shows smaller effects than brisk walking or running. Research on the timeline of exercise-induced cognitive improvements shows that different effects emerge at different time points. Within the first 20 minutes of a single aerobic session, attention and processing speed improve. Acute BDNF and catecholamine effects. Over 2 to 4 weeks of regular training, working memory and executive function improve as baseline BDNF elevation is established. Over 3 to 6 months of consistent aerobic training, measurable hippocampal volume growth occurs on MRI, the structural change underlying long-term memory. Based on the neuroscience research, here is the specific exercise protocol for cognitive optimization. Perform 30 to 45 minutes of moderate to vigorous aerobic exercise at least 4 days per week. Aim for 65 to 75% of your maximum heart rate, the intensity that produces peak BDNF elevation. Time your exercise in the morning when possible. Then follow it with your most cognitively demanding work while BDNF is elevated. The research logic for exercise and cognition is unambiguous. If you exercise aerobically for 30 minutes at moderate intensity, then BDNF rises 20 to 30% within that session, improving attention and memory encoding acutely. If you sustain this routine for 3 to 6 months, then hippocampal neurogenesis accumulates and volume grows measurably on MRI. Structural intelligence infrastructure is being built. The simplest, most evidence-supported habit for becoming smarter is aerobic exercise. Research has demonstrated that it physically grows the hippocampus, raises BDNF, the brain's growth factor, and produces measurable improvements in memory, attention, processing speed, and executive function. The PNAS trial showed 2% hippocampal growth in 1 year with walking alone. No supplement, no brain game, no educational program has replicated this effect size. The research has settled the most important question in cognitive enhancement. The most powerful tool available is not a supplement, not a technique, and not a device. It is aerobic exercise. 30 minutes, 4 days a week, at a pace where you can talk but not sing. Start tomorrow morning. Follow it with your most important cognitive work of the day. Do it consistently for 6 months.